Alright, so on number 7, it's a little bit different than anything that we've seen before. So I wanted to help us with the setup. So notice that we have 1 divided by 4x squared plus 9 dx. So our problem is that my first instinct, which is probably like a lot of yours, would be to let my u be my denominator, because my outside function would be 1 divided by stuff. So if I let my u be 4x squared plus 9, I would get 1 over u, and we know that's the natural log. The issue that we run into is when we take the derivative, we get 8x dx. And so we can divide by the 8 pretty easily to get the dx by itself. But then we have an x left over, which we ran into one like this in our notes. The problem here is, in order for me to be able to then substitute that, I would need to be able to solve this first equation for x in order to put it with u's. And this is not going to be fun to try and do. So I see that that one doesn't work. And so this is kind of one where it's kind of a process of elimination. So I see that my first instinct didn't work. So I need to do something else. Remember, our goal here is first to use our power rule, if at all possible, or to use something that we know the integral of. So like we said, I know that the integral of 1 divided by u is the natural log of u. The other one that we should know, it's been a little bit, but remember that our derivative of the inverse of tangent of x is 1 divided by x squared plus 1. So if we can get this to look like 1 divided by u squared plus 1, we would end up with tangent inverse of u when we take the antiderivative. And we're almost there. We have stuff that's being squared. So notice that 4x squared could be written as 2x squared. So in this case, I could let my u be 2x, and I would have u squared. The problem is that then I don't have a plus 1, which is what we need. We don't need a 9 there. So if it was just 4x squared plus 1, then we could just do it this way and let our u be 2x. But because it's not, we have to take care of that 9 first. So what I'm going to do is factor out a 9. So notice that when we do that, okay, factoring out is basically the same thing as dividing. 9 does not go into 4, so we would just be left with 4 ninths, x squared. And then we have plus 1. So now I want to do the same thing that I thought about doing here, except with a 4 ninths instead. So notice that 4 ninths would give me 2/3 x quantity squared. So now I have 2/3 x quantity squared plus 1 gx. So my 1/9 is a constant, so I'm going to bring that out to the front. And now notice that it is in that form that we want. It's something squared plus 1, which is what we said we needed. So now we can let our u be 2/3 x, which means that my du would be 2/3 dx. So we don't have a 2/3 hanging out anywhere, so I would need to divide by 2/3, which is the same thing as multiplying by 3/2. So I get that. So then notice that I have a 3 on top. This is also a constant, and I'm multiplying, so we can bring it out to the front. My 3 is going to reduce with my 9 3 times, and so we would just have 1/3 times 1/2, so we get 1/6 in the front. So we get that. So then, like I said, the antiderivative of this is going to be, so I'm going backwards, I would get tangent inverse of u. And then we would need to switch our bounds the same way that we've been switching them. So we would need to plug in our 2 bounds that we already have and get our new u bounds. And that's what we're going to plug in. So whatever we get there. Okay? And then we should be able to plug it in the rest of the way.